A very good morning to Pan Fazian and my fellow friends. I'm Gordon from Group 2. So now, me and my group members are going to present our group assignment, which is IoT in construction management. So, what is Internet of Things? Internet of Things IoT in construction management refers to the utilization of IoT device, sensors, and data analysis to enhance the planning, execution, and overall management of construction projects. By connecting physical objects and collecting real-time data, IoT enables construction companies to improve efficiency, productivity, safety, and decision-making throughout the construction life cycle. There are various devices and sensors are deployed across construction sites to gather data on equipment uses, workers' activities, environmental conditions, and more. This data is then transmitted to a central system where it can be analyzed and used to derive valuable insights. These insights help project managers and stakeholders make informed decisions, optimize workflows, allocate resources effectively, and ensure project milestones are met. For example, sensors can be attached to construction equipment and machinery to monitor their performance, uses, and maintenance needs. By collecting data on parameters such as fuel consumption, engine health, or equipment utilization, we can schedule preventive maintenance and optimize equipment uses and minimize unexpected breakdowns that could lead to accidents. Therefore, IoT in construction management represents a transformative approach to enhance efficiency, productivity, and safety in the construction industry. By leveraging real-time data, analysis, and connectivity, construction companies can optimize workflows, make data-driven decisions, and deliver successful projects. Embracing IoT technology can unlock significant opportunities for the construction industry and pave the way for a more connected and intelligent future in construction management. So now I will pass the turn to my group members and they are going to discuss what are the Internet of Things in the stormwater management and road tunnel which we call SMART that has been built in Kuala Lumpur.
Very good morning to the Fajian. My name is Ng Zheng Kang. My matric number is AP210179. Now I will continue to present about the SMART. So what is SMART? SMART stands for Stormwater Management and Road Tunnel. SMART is a storm drainage and road structure in the Kuala Lumpur, Malaysia, and is a major national project in the country. It is the longest stormwater drainage tunnel in the Southeast Asia and second longest in Asia. The tunnel has a diameter of 33.2 meters and comprises of a 9.7 kilometer stormwater bypass tunnel with an integrated 4 kilometer road deck road. For the main objective of this tunnel is to solve the problem of flash floods in the Kuala Lumpur and to reduce the traffic jams along the Jangan Sungai Besi and Rockview flyover at Pudu during the rush hour. There are two components of this tunnel. The first one is stormwater tunnel and the second one is motorway tunnel. In 2011, the Smart Tunnel received the UN Habitat Score of Honor Award for its innovative and unique management of stormwater and peak hour traffic. This tunnel in its own capacity could address 45% of the Klang Valley's major faults, especially within the flood-prone areas such as Masjid Jamil, Dataran Merdeka, Rebul Ambang, and Jalan Melaka. It begins at Kampung Perembang, right near Klang River, Ampang, and ends at Taman Desert, right near Kelanyong River, and Salah South. The project is led by the government, including Malaysia Highway Authority, which is Lembaga Lebuh Malaysia (LLM), and the Department of Irrigation and Drainage Malaysia, Jabatan Pengairan dan Saliran (JPS), and also the company, namely MNC Corporate Berhad Gamuda Berhad Joint Venture, is primarily to mitigate the recurring fall in the city of Kuala Lumpur, the financial, business, and commercial hub of Malaysia. However, at the design stage of SMART, The dual purpose concept was born from the ingenuity of the project proponents, and the motorway tunnels was integrated into the system to reduce the traffic congestion at the main southern gateway to the city center. However, the smart system will be able to divert large volumes of fall water from entering this critical stretch by a holding pond, bypass tunnel, and storage reservoir. It will help to reduce the fall water level at the Jalan Tumpera Bridge and preventing the spillover. Besides, the other benefit of smart is the motorway to ease the congestion. The motorway tunnel will provide an alternative route for the motorists from the Southern Gateway, KL Seremban Highway, Federal Highway, Best Raya, and East-West Link entering and exiting the city center. This will help to reduce the traffic congestion at the Southern Gateway leading to the city center. The traffic time will be reduced significantly. For example, from the Jalan Istana interchange to the Kampong Panda, the expected travel time is 4 minutes compared to 10 to 15 minutes using the existing roads. Okay, before I pass to my teammate to continue the following part, so let us see at the right side first. So as you can see at the right side is the IoT technology may use in the tunnel. So these are the picture of the IoT technology. For example, like tunnel lighting, tunnel sensor, and tunnel closest CCTV. So this type of application will help to provide the real-time information to the passenger to avoid the fast fall and the traffic congestion. So that's all for me. So now I will pass to my teammate to continue the following part. Thank you.
Thank you, my partner. Now I'm Tae Chong, AP 2210417. I will present the mode of the smart tunnel. The smart tunnel consists of three sections. The upper two sections are roadways that cater the traffic, and each section allows the traffic to travel in one direction only. The third section is strong water tunnel. Under the snowstorm, the mode is activated, the traffic tunnel is open, and the stormwater tunnel is closed. The tunnel will operate as a normal traffic tunnel, and no flood water is diverted into the stormwater tunnel. During the moderate storm, the mode is activated, the strong water is diverted into the strong water tunnel. Meanwhile, the two upper roads are still operate as usual. In the major storm, the mode is activated when the flood indicates a flood rate at least 150 cubic per meters. Only 10 cubic per meters will be released into city to control the flood. In 2 to 8 hours, the road tunnel will be safe and return the traffic as usual. When the heavy storm strikes the city, the mode 4 will activated. The upper two road will are closed to traffic evacuated. Thus, the entire three section of the smart is ready to carry floodwater. The automated water light gate will be opened to allow the floodwater to pass through after the floodwater was ended. The tunnel is verified and clean well pressure washing in the roadway will be reopened to traffic 48 hours of closure.
My name is Lin Xiao. Now I want to presentation is about the flat detection system (FDS). FDS in Smart has provided early forecast information so that efficient and safe management can be made during tunnel operations. The FDS system consists of hydrology and hydrodynamics models database, and scheduler. Hydrological rainfall runoff models play an important role in providing early warning for tunnel opening by using real-time rainfall data obtained from the upper catchments and surrounding areas. The models effectively predicting stream flow by estimating runoff generated during rainfall events. Now I want to presentation is about the traffic management and control system (TMCS). TMCS in the smart tunnel utilizes the SCADA system for efficient traffic flow and emergency response. The fundamental and vital electrical and mechanical equipment in the tunnel is continually analyzed, processed, and controlled by the SCADA system. The smart tunnel has proven effective in fleet management and traffic control, but it is mainly designed for smaller scale fleet and cannot handle heavy rainfall or saturated catchments.
Hi, my name is Hoi Jing Xuan. My metric number is AP210499. Now I will continue present about my part. The historical data reveals that the smart tunnel is rather required due to the majority of major flood begin minor. Less than 50% of the flood is significant enough to consider using the tunnel. The tunnel is divided into three sections. Each operate independently with floodgate due to the presence of root that its main purpose is to prevent smaller scale flood. However, the tunnel cannot be considered a comprehensive flood defense system as it would not be able to handle heavy rainfall or saturated catchment and flood defect. On the positive side, the smart tunnel has effective diverted flow water from the Klang River since its construction in 2007. As a result, there has been not spot flood in the target area. It has been analyzed over 18 times for flood management purpose, showcasing its effective in protecting specializing location. In terms of traffic flow, the smart tunnel serves as pathway for more than 30,000 daily commuters and has been 95% effective in reducing traffic in the city core. But there is still a 5% risk of an issue with traffic flow. The monthly maintenance tasks are carried out according to the tunnel operating handbook. Regular check and maintenance of the highway system, software, and watertight gate and consider vital to ensure the tunnel functionality and optimal performance. Cleaning the tunnel on a weekly and monthly basis is also emphasis for effective flood management, road clearance, and fulfilling the tunnel primary function. Overall, while the smart tunnel used for flood prevention is relatively rare due to the prevent of minor flood, it has demonstrated its effectiveness in preventing flood water and providing traffic relief in Kuala Lumpur. The considered implementation of maintenance tasks is crucial to uphold its functionality and ensure the protection of target area. Here you can see got two graphs show that the number of flood occurrence for 1999 to 2014 and number of traffic division for 1999 to 2014. So the result can see before using the smart tunnel and after using the smart tunnel, the number that is decreased. So that's all for here for my presentation. Thank you.
Hi, I'm Chuan Hong from BPC, and now I'm going to present about suggestion based on the problem statement that is out. The first one is flood. Malaysia was hit by a damaging natural disaster, heavy rains cause flood and landslide over the country. Danger warning in continuous heavy rainfall exceeding 240 mm per day in Johor, for example, Kluang, Mersing, Kulai, Kota Tinggi, and Johor Bahru. A surf warning in Pahang, Pekan and Ropin, and alert in Perak and Terengganu. The disaster had a significant impact, affecting numerous families and communities across the country. Roads, bridges, infrastructure suffered damage, with 98 flood-affected areas and 21 landslides reported by Department of Public Work (JKR). Over 46,000 individuals from 13,336 households were affected and sought refuge in 250 evacuation centers established by the National Disaster Management Agency (NADMA). Families from particular affected states like Johor, Malacca, and Pahang were relocated to centers in various cities and towns. For this problem statement flood, I will be present about the suggestion was the stormwater management and road tunnel smart system in Kuala Lumpur has proven that effective in mitigating flooding and reducing traffic congestion during the peak hour. However, other flood-prone areas in Malaysia lack of similar infrastructure and solution to combat flooding and landslide. It is essential to extend stormwater management system such as flood detection system (FDS) in stormwater bypass tunnel to states like Johor, Pahang, Perak, which have experienced flooding. The government should prioritize the implementation of these systems and collaborate with federal and state authorities as well as engage relevant stakeholders. The last was investing in infrastructure improvements and sustainable urban planning strategy will create a more livable and resilient environment for affected communities. Thank you. The next suggestion, based on the second problem statement, is traffic congestion. There are three crises for this issue, that is tracking delays, pollution, and wasted resources. Taking delays in 2022, it took an average Malaysian drivers 16 minutes and 10 seconds to travel around 10 kilometers, an increase of 1 minute and 40 seconds from the previous year. On average, Malaysian drivers spent 159 hours on the route in 2022, with 75 hours attributed to traffic congestion. The next crisis is pollution. Each driver emitted around 833 kg of CO2 per year, with 180 kg specifically attributed to traffic congestion. It would take 83 trees a year to absorb these carbon emissions. The third crisis is wasted resources. The average Malaysian vehicles consume around Rm 1023 ringgit worth of fuel in a year, with Rm 221 wasted due to Spain on the traffic jam. So the suggestion that I will give to this issue, problem statement, traffic congestion, will be implement traffic management and control system (TMCS) to allow quick and effective control of vehicles entering, inside, and exiting the tunnel. Then implement a comprehensive public transport system in Kuala Lumpur or in other states that facing the same problem, traffic congestion. And then expand and improve existing public transport infrastructure, enhance the quality of frequency of public transport service, utilize smart technology and real-time data analysis for route optimization, and provide park and ride facilities, enhance the first and last mile of connectivity. And the last suggestion will be implement dedicated bus lane and prioritize public transport at traffic signals. Thank you.
Hi, I'm Chokai and I will make a conclusion for this slide. And Gamuda Berhad is a reputable company with expertise in infrastructure development, construction, and engineering service. For the first problem statement flood, Gamuda Berhad can implement sustainable drainage system and flood control infrastructure to mitigate the risk of flooding in Kuala Lumpur. Collaboration with city authorities and engagement with local community are essential to ensure effective and well-received flood management solutions. And the second is traffic congestions. Gamuda can address traffic congestion in Kuala Lumpur through the implementations of smart transportation system and urban planning strategy. Collaborating with stakeholders and considering the needs and aspirations of residents will help ensure the success of this traffic management initiative. The third one is social responsibility and sustainability. Kamuna commitment to community engagement and include planning process set it apart as a partner for sustainable development. The company actively listen to the needs and concerns of local community and incorporate their feedback into project design. Gamuda emphasis on environmental sustainability include the use of eco-friendly materials, preservation of green space, and integration of nature-based solutions in its project. Overall, Gamuda expertise in flood management and traffic congestions, coupled with its commitment to social responsibility and sustainability, position it as an ideal partner for Kuala Lumpur in achieving a sustainable and resilient future for the city. That's all for our slide. We are Group 2. Thank you.